Okay, so Unit 7, Unit 7 is all about inference for quantitative variables. So one of the things is, now that we're getting to Unit 7, one of the things I want us to be able to start thinking through is, how do you decide what kind of procedure we should do? And so some of the things you want to think about is you essentially have kind of 4 different kind of umbrellas that our tests are over, okay? And so those are my umbrellas. So the first one is proportions. In other words, what we have is what the information you are getting in the sample is about either p hat or more than one p hat, okay? Then you have means. Then you have relationships. And then I'm going to kind of have this one other one. So I could call it 3 if you really wanted to. So for proportions, you essentially have every single procedure you're gonna have are Z procedures. So Z tests, Z intervals, or a chi-squared goodness of fit. Okay, and so you would pick the Z procedures if you have 1 or 2 proportions in the problem. And you would pick the chi-squared goodness of fit if you have more than 2 proportions in your problem, okay? So, yeah, all right. And if it's means, for means, somewhere in the question you're going to be given X bar. You might have more than one X bar. And then if that's the case, you're going to do some sort of T procedure. And that's, as most of this video will be about the different possible T procedures, okay? And then if it's about relationships, it's either going to be, you're either going to have a two-way table, or you're going to have a scatter plot, right? And so that's our last video. And so, like, if it's about relationships, if you're given the two-way table, that's going to be a chi-square test for either association or homogeneity. Again, we'll talk about those a little bit more on Monday. Or if you're given a scatter plot, it's going to be a T test, or a T procedure, I should say. Because it could be an interval, it could be a T procedure for beta, okay? Which is that slope. And pretty much everything follows either, if it's proportions, it's going to be Z, unless you got a whole bunch of them, and then that'll be chi-squared. If it's means, it'll be T. And if it's any of those like kind of funky relationship questions, like relationship between 2 different variables, that will be either this chi-square test or a T procedure. So first thing you would do is decide, is it Z or T? And then you might ask how many samples, because that'll tell you whether or not you're doing a 1 sample Z interval or a 1 sample T interval or 2 sample T interval or whatever. So, and keeping in mind that we also then have paired T procedures as well, which we'll talk about on the back page of this. All right, so just kind of like keeping in mind, one of the things, like, so far you've had all our problems have not been mixed together all that much. But when you take the final or when you take the AP exam, you won't be told what unit something comes out of, okay? All right. Now, the other thing is we switched to T for means, and I know we kind of talked about this already, but I'm going to talk about it again. So the big thing is my standard error of the means, so S of the X bars, is S over the square root of N. And that S is from the sample. And so we really don't like that we have to use a sample value for the standard deviation because the standard deviation of X bars, like if we're looking at the big picture, if we actually know our population, is the population standard deviation divided by the square root of M. And essentially, we have to use the sample value because we don't have anything else, and we know the sample value is not a great value. Okay, so that's why we choose T for means. But it's, you need to know, are we doing means or proportions, because that kind of helps us decide what kind of procedure we want to do. And then the other component is just like a little cue to help you with this. Kind of like a little saying that a lot of AP Stats teachers use. We are meant to give props, where Z goes with the proportions and T goes with means. And it's supposed to be like, it kind of dates us because it makes me feel old. But like in my day, you would call somebody, if you were giving somebody a compliment, you're giving them props. And so that's kind of what but it doesn't really fit as much with your guys' vernacular anymore. But anyway. Okay, so it turns out that we kind of talked about all of this, the rest of this page, when we did the Unit 5 key ideas, where we talked about, even that T for means, and we talked about the different types of inference with the Unit 6 ideas. Okay, so I'm not going to worry about those, and we worked this exact example in the Unit 5 key ideas, so but we're going to kind of jump straight to inference for means that we talked about. So when we're talking about inference for means, we still have those similar conditions for random, normal, and independent. Those conditions change a little bit here. So the random condition is either going to be from random sampling or selection. And if that's the case, we check our independence condition with that 10%. Our sample size is less than 10% of our population size. Okay. And if we could also select it by random assignment of treatments. So if our treatments are randomly assigned, or when we get down to it and we talk about paired procedures, if the order of the treatments is randomly assigned, we check that condition by saying individual responses to the treatments are independent. Okay, and then lastly, the normal condition for means, you can't use NP and N1 minus P greater than or equal to 10 because means are in fact don't have an N or don't have a P. So the easiest way to do it is if we have a large enough sample size, we say that then with 30 being kind of like our boundary, that even though the population isn't normal, we can still say that that if I took every possible mean, just a reminder of what has to be normal is not the population, but rather what the predicted set of means would look like. And so those means will be approximately normal if my sample size is greater than or equal to 30. Or if my sample size is less than 30, we look at a graph of the sample. And the basic idea is if even if my sample size isn't greater, like even if I'm sampling from a normal population or a well-behaved population, as long as my population's pretty symmetric and pretty well-behaved, then we can assume that those X bars will still be normal, okay? And so what we look for is in the sample, what we look for is, does it seem reasonable from the sample that we're coming from a well-behaved, like well put together population? And so what we look for it as, like, if I have no major skewness or outliers in my sample, then it's reasonable to assume that there's no major skewness or outliers in my population, so I can still assume those X bars will be normal, okay? All right, now, the procedures that we pick in our calculator, we essentially have 6, but if what we're dealing with is means, but in reality, you're only going to talk about 4 of these. So we have a t interval for mu, and that is x bar plus or minus t star times s over the square root of n. And a reminder for that t distribution that your degrees of freedom is equal to your sample size minus 1 when we're dealing with means. If I have two different sample means, I'm going to call them x bar A and x bar B. What I would be estimating, I use 1 and 2, so let me be consistent here. My point estimate is going to be the difference between my two sample means. I will still have a t star, and then my standard error will be s1 squared over n1, the square root of s1 squared over n1, s2 squared over n2. All right, that being said, this is the t int in your calculator. This is the 2 sample t int. You're never going to use these formulas, okay? All right, there is technically one sample. This is not supposed to be z. This is supposed to be t. And the biggest piece here is that your t statistic is calculated by saying your x bar minus the mean written in your null hypothesis over s over the square root of n. Again, in your calculator, you're just going to pick t-test. And likewise, there is a t statistic for the 2 sample t-test. It would be x bar 1 minus x bar 2 minus 0 over s1 squared over n1 plus s2 squared over n2. But again, we haven't been doing any of these by hand for a reason, okay? You're just going to pick the 2 sample t-test in your calculator for this. Okay. All right. And then lastly, we've spent a little bit of time talking about paired t-intervals for mu d or paired t-test for mu d. And for paired procedures, we'll talk about it at the bottom here. Obviously, you can say I want to talk about the difference between, say, paired and 2 sample. The biggest piece is, all right, so then what you're going to have is you're going to have values for the differences. And when we talk about the differences, when we have paired data, there's going to be the ability to do individual comparisons. Think about like a twin study or a before and after study. If I'm looking at something that's before and then after, really what I'm going to do is for each individual, I would do after minus before or vice versa. And so for each group, I would have a difference. This D is the mean of the differences, okay? So you would still pick T interval. And if it's a test, you would still pick t-test in your calculator. Your interval would still be x bar. It would be very similar to the regular t interval. The only difference is that x bar is going to be the x bar of your differences. And then likewise, your degrees of freedom are how many differences you have, -1. So not both groups -1, but just the differences -1. And here, again, our t-value would be the mean of our differences -0 over s over the square root of n. But that would be the s, again, of the differences. And likewise, this is s of the differences. So the biggest component is that if it's paired, you're basically doing the same thing as you would for a one sample in terms of what you put in the calculator, how you do your calculations. The only difference is you're doing that on a list of differences. So some other components here is if you're running tests, your hypotheses are going to be about either mu1 compared to mu2, or mu-d, if you're doing hypotheses, because that's my population parameter. Okay, so now, lastly, you need to be able to choose, should you be doing a paired procedure or a two-sample procedure? All right, so the basic premise is for paired data, you are allowed to directly compare two individual observations. And essentially, when we say directly compare, that really means subtract. Okay, so for example, I'm going to kind of draw this up in this margin here. Okay, for example, if we were to give have everybody complete a task with their right hand and with their left hand. Okay, so let's say the task is how many, think about a yo-yo, and someone's playing with a yo-yo, and how many times before they screw it up, okay? And you'll have people do it with their right hand and their left hand. I'm going to change that already to dominant versus non-dominant hand. Okay, so let's say I go down the hallway and I start with Mrs. Downer and I give her a yo-yo and I say, with your dominant hand, just throw the yo-yo back and forth, up, down and up, down and up, down and up. How many times will it take you to do that before it gets all twisted or it can't work? And let's go ahead and say for Mrs. Downer, it was 5 times with her dominant hand, 2 times with her non-dominant hand. And then Meister tries it, and it's 6 times and 1 time. And then Richards tries it, and it's 4 times and 2 times. And then Turner tries it, and it's 8 times and 6 times, so on and so forth, okay? In reality, this would be paired data because I'm allowed to directly compare this number and this number. They both came from Mrs. Downer. These both came from the same person. These both came from the same person, and so on and so forth. And so in this particular case, because I'm allowed to directly compare, I would find the difference for each teacher. So this would become 3, 5, 2, and 2. And this is the list that I would run my inference procedure on, okay? Whether I do a paired t-interval or a paired t-test. That would be paired, okay? Now, same idea with the yo-yo, where we have someone playing with a yo-yo as many times until they screw it up. But this time what I'm going to do is I'm going to have students do it. So I'm going around the room and I get a couple of students, or down the hallway again, a couple of students from Mrs. Downer's class. And let's see, the 2 students that I pulled from Mrs. Downer's class can do the yo-yo 8 times and 10 times. And then the 2 students from Meister's class do it 11 times and 6 times, and then 2 students from Richard's class, and it's 4 and 7, and then 2 students from Turner's class of 8 and 2. And then I also asked some staff members. So I have my 5, 6, 4, 8 from the math department, but then I go and ask Mr. Wapner, and he can do it 3 times, and then Dr. Lee can do it 10 times, and so on and so forth. As I look at this one, there's no reason to directly compare this student to this staff member. So for this one, I would find this, the X bar for this group and the X bar for this group. I would find the means first, and then I would compare those two sample means. So I'm going to call this S, and I'll call this one T for teachers to kind of help that through. Okay. So here, I can directly compare. Up here, I can directly compare individual observations, so it's paired. Here I cannot, so this would be 2 samples. So just to kind of help you guys make that distinction, this one would be a paired t-test or a paired t-interval, whereas this one would be 2-sample t-test or 2-sample t-interval. Okay, so other than that, how do you write your hypotheses, p-value, all that kind of stuff is done the exact same way as all the procedures that we talked about in Unit 6. You could still, for the tests here, or the confidence intervals here, all of those rules still apply. But they just look a little bit different. So hopefully this helps, and I will talk to you guys on Monday.